It's nothing.
Yeah, yeah.
It doesn't mean anything. The financial fair play. It's crazy.
Anyway,
Just
Man City had the money, and Man City have the squad. So yeah, they and most likely they can bounce back next year.
no, like this is so frustrating because financial fair play exists for a reason,
Hmm.
right? And then suddenly, just financial fair play, like they exist for a reason.
Hmm.
Like for Man City
Hmm.
to 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 survive and still be able to play in Europe is pretty humiliating because at this point we just know that it does the financial fair play doesn't really mean anything because it states that because this time the evidence presented is enough to prove them City is in trouble. Right? They've done it. They have not applied with the financial fair play, but these evidence cannot be used
You,
because they're because these sources are so acclaimed unreliable and not legal. So to get inside information right now, anything is illegal and nothing can be done as evidence. So right now, this ending the Newcastle is being bought by a team, and then just it's a fucking wank fest because everybody can spend as much money as they want right now.
you no, you should know, especially during this COVID-19 lockdown, so many besides clubs, so many companies or so many institutions, whether it's football, basketball, they are in need of money. And who can give them the money? Man City, the boss, right? So everybody
Uh,
is looking for money, and Man City has the money. So any problem can be solved by money right now. Okay. So
and also by doing this, right? People are, like a lot of big oil rigs of the
yeah.
Middle East. They're 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 scared that financial fair play is gonna like financial fair play because of financial fair play. They're I don't know like it will limit their ability to buy players.
Mm-hmm.
Right? They cannot just come in and do what Man City did and buy a bunch of players and immediately become a contender. Right now they can.
Yeah.
So the Arabians buying Newcastle
Mm-hmm.
is a new thing. Now the Big Six has become Big Seven.
Mm. Yep. So the whole point here is in times like this financial crisis, everyone is in need of money. So moral grounds, please set aside. Okay, the world runs on money. All right, so simple as that.
It's not even about that. It's like if a rule is set right, it has to be kept by the top guy.
Wait, you need to understand one thing. If you talk about rules right now, and and no, if there are no institution, there will not be rules. Okay, if football is if football is gone, and then you don't have rules. Okay, you need to make sure that the clubs are around and games are played. Then only you can talk about rules. So nowadays they have to make sure. These days even some of the leagues are cancelled, and okay, you don't make money by canceling your games, right? So it's all about those. It's all about the financial rewards at the end of the day, right? So that's why they have to keep Man City afloat. They have to let them play. If not, there are no games. FIFA, the FIFA president or the members of FIFA or whoever is in charge of FIFA, they are they are paid. They are paid by somebody, so somebody has to pay them. So they can't like, oh, I have to enforce these rules, and Man City is not supposed to play next season. Okay? Especially during the lockdown. Okay? Especially during the lockdown. All right. So, yeah, hope Arsenal
The
is.
thing is, right? No matter what it is, because it's a such a more impact than everybody would think.
Mm-hmm,
So people are scared, like these big clubs, like Paris, like these things, right?
mm-hmm,
They're being investigated. They have to be careful
mm.
of their actions because they will be punished per se
If
because
when you
they will be
when you
punished for
when you put a
for
case
spending
in
too much
court,
money.
right? If you put a case in court, so lawyers are. I mean, the rich can actually hire lawyers to win cases. So I think this is also another perspective you can look at this event. So okay, somebody brought a case to the court and saying, oh, somebody broke the rule, like Man City broke the fair play rule or whatever. But at the end of the day, they can hire the best lawyers to argue against that, or to argue
No,
against, right? So ultimately,
it's
the best
not
lawyer
even about
to be
that.
hired by the rich and
No, it's
get
not even about that. You know,
mm-hmm,
it's not even about that.
mm-hmm. But anyway, good.
It's about you.
Arsenal.
You see the football market, right? Everybody thought that after this lockdown, everything's gonna be a lot cheaper because nobody has cash,
No,
right?
no. I mean, the even I mean players like no. I mean these days the okay that you expect something to go down, right? But what you see here is you are not going to see things go down. You don't see the value of things go down. You only see the gap between the rich and the poor get widened. That's the fact.
Yeah,
Okay.
exactly.
Yep.
Because the lockdown happened, so
Yep.
so the teams now have less money to work with,
Yes.
and right now everybody's hoping for this like absolute like bubbled
Yep. The bubble is not. Is not.
player market to have a like take a break. Everybody's wanting to see that, but financial fair play right now, there's no point because it's not gonna nothing is gonna happen.
Mm,
It's gonna be get more expensive because there are more capital
yes.
coming into play,
Yeah.
and
So
then nothing is limiting these capitals.
I don't believe.
And then what is it going to result on? It's going to result on higher ticket prices,
Mm,
people like trying their best to sell players
mm,
and having extremely like sick league with only like one contender which has the most money
exactly. That
and
happens.
young players. There's no point, right? There's no point of developing young players because they're going to get sold to the bigger clubs, to the one club, to the two club, every single one of them.
So if you're talking about this what football market, right? So the whatever happened in the football market, it happens in the world right now. Okay, because of this lockdown, the rich probably get slightly less rich, but the poor really get so much poorer. Okay, so the gap between the rich and the poor it just gets widened. Okay, the rich still stay there on top. They just get less rich, not so rich, while they can accelerate their wealth so much faster if there is no lockdown. But for the poor is really suffering like hell. So basically, you see there is this big divide between them. It's going to get widened. Okay, the rich will just stay there. Okay, they are not like so much affected. The same thing happened to the clubs, right?
Yes, exactly. That's what the financial fair play is created. So the bigger clubs cannot expend as much money as they want to limit the gap between the players, between the clubs, right? And right now, if things like that is going to happen, then every league is going to have a dominant figure, so to speak,
By the
and
way,
then they're
the,
going to have all the players, all the money, and their money is not made from football.
by the way, you see it happening in Chinese Super League as well, right? Right? You see it happening in Spanish league. Okay, uh, the candidates for champions in Spanish league is either Barcelona or Real Madrid. If you look at their record, all right,
Yeah.
yeah. And if you look at the China Super League, I think Heng Da, yeah. You look at the English league, right? So Man City, right? You look at the French league, what PSG, do you see any like other candidates between these? You don't see, right? So it has been happening, okay? Whether with the financial fair play law or without, the status quo is still happen.
It's better for the clubs, but it's worse for football because all we wanted is competitive, close football, and right now nothing has been done to keep that afloat.
In fact, this thing happens in the this thing doesn't happen in the football market. I mean, it happens everywhere in the world. You look at the US, the biggest company are Apple and then Microsoft and Amazon. The rest, they are just they are probably bordering bankruptcy right now, especially with department stores and stuff. JC Penney bankrupt, right? So Amazon is doing quite well, right? Okay, but Arsenal is doing well, so that's something you should be very happy about. Okay, so I think
I am, but not really,
oh,
because financial fair play bullshit.
okay,
Nobody is happy right now.
okay. Yeah. The system.
It's just sad.
Yeah.
It's really sad that it's to be expected. Money can do whatever they want.
Yeah.
Because they have cash, but it's just it's sad.
Yeah.
It's just sad.
All right. So yeah. So I think we had a very good discussion on the previous chapter, which is here. I hope you can see my screen. Chapter 14 on statistics. We talk about the benefits of using standard deviation over spread and over range and interquartile range. So we had a very good discussion on this topic, chapter 14. We went through almost all questions. So now let's look at the next chapter, which is probability. All right.
Yeah.
Or is there another chapter that you are more interested in knowing?
No, not really.
Okay, then let's move on to the next chapter, probability. All right. So, okay. Wait. I thought we talked about this before we talk about that. I thought we talked about the one standard deviation and two standard deviation, right? The question.
Yeah, we did. Yeah.
Which is this normal curve, right? Okay, so never mind. We'll move on to this probability question. I mean this chapter. Okay. Over here it says that an impossible event which has 0% chance of happening is assigned a probability of 0. And a certain event which has 100% chance of happening is assigned a probability of 1. So all other events can be assigned a probability between 0 and 1. So it's from impossible to very certain, all right? And this is how all events will fall into this 0 to 1 spectrum. Okay, for this, on the extreme left is impossible, and then the extreme right is 100% for sure, certain. And then there is a spectrum here. So somewhere here is very unlikely to happen, and then somewhere here is very likely to happen. In the middle is equal chance of happening as not happening. It's just like you toss a coin, the chances of getting a head or a tail is half. All right. So the development of modern probability theory began in this 1653, and this guy Pascal. Okay. So do you know why we want to learn about probability?
So we can calculate the probability.
Okay. If we have no concept of probability, so let me just give you an example. So the significance of probability is it's very, very significant, yeah. I would say. Without probability, I think it's hard to make decision actually. So let me get my writing pad quickly. Okay, so like we discussed just now, so you have this spectrum of probability. So let me just get a straight line out of this. All right, so the extreme left you have 0, and on the extreme right, so this is a probability of 1. So over here it means 100% certain. Here over here is impossible. So every event falls between 0 and 1. All right. So I will call this the probability spectrum. Probability spectrum. Okay. So let's say if you have no idea of probability, right? So let's say if you were to, you know recently the China market, the stock market. Have you heard of the recent China stock market?
No, not paying attention.
Are you okay? Never mind if you are not paying attention, but the China stock market recently had a bull run. Okay, had a bull run. Okay, so
that's odd.
Pardon?
That's odd.
Yeah. So so all of a sudden, China stock market had a bull run, right? So if you have no concept of probability, okay, you have no concept of probability. So let me just give you a task, okay? So what do you think on Monday? Monday is tomorrow, so it's today is 19 July 2020. What do you think will happen tomorrow?
Keep going.
Stock market tomorrow, China stock market. So
what?
The chance of it going up and the chance of it going down is actually 50-50, right?
Yeah.
Actually, if I were to simplify it into just up and down, right? So you get a chance of 50% going up, a chance of 50% going down. Actually, there is a third possibility. It's flat. Okay, it can be flat. So the chances of this will be changed to 1/3, 1/3, and 1/3. Am I right?
Yeah.
So these represent it will go up. This will be flat. That means it doesn't move at all, and then it will go down, right?
Yeah.
So the chances of it going up is 1/3, flat is 1/3, down is 1/3. All right. But if I gave you information like, oh, the China market had a bull run.
Yeah.
And then this simple information here might affect your decision making.
Yeah.
Am I right?
Yeah.
It might affect your decision making. So since it had a bull run for the past week, you might think it had a higher chance of going up. Okay, you might think it had a higher chance of going up tomorrow on Monday when the market opens tomorrow, right? Compared to the other two probability, flat or down. You might think that the chance of it going up might be half, and then over here might be 1/4 and 1/4. All right.
Right.
So if you have this idea, okay, if you have this idea like of it, it might go up tomorrow, half of the chance. So you want to bet the market go up tomorrow, right?
Right. Yeah.
Chances of it going up is half compared to the rest, right? But that is only your idea. This is your idea, okay, or your intuition, okay. That means it's just your sixth sense. You know your sixth sense.
Yeah.
It's your sixth sense. Okay? It might not be a fact. Okay, it's just your sixth sense. So that is the concept of probability playing a part in our daily life. All right.
Yeah.
Okay. So you tend to bet. You tend to bet for the idea that has a higher chance of realizing in real life. Okay. You tend to bet against. Okay. You tend to bet against ideas that have a lower chance of happening. Okay.
Right.
So that is the concept of probability we use in our daily life decision making. All right. So that's the reason why we want to have we want to learn probability. If not, if you have no idea of probability at all, what you are doing is basically you're guessing.
Yeah.
Okay, you're guessing. Okay, but you know, right? When you guess, basically you have no idea. That's why you guess. Okay, when you have no idea, that's why you guess. But if you make use of the concept of probability, your guess is actually, I will say, a smarter guess. Okay, a smarter guess. All right, if you make use of the concept of probability. All right, so a smarter guess is better than a guess. So that's why when civilization evolves, and then people start to have the concept of probability, and then we start to make a smarter guess about the future. All right, future is uncertain, but we can either guess or have a smarter guess. So I hope we fall into this group of people, okay, who make smarter guess. All right, that's why we want to learn about the concept of probability. All right, so that's the significance of the concept of probability. Right now,
Yeah.
so over here, opening problem. So over here, you see a live table, okay, and you see a live table for the male population and the female population. All right. So in each age range, okay, you see the number of surviving, and then you see the expected remaining life. All right. So what do you see here is a table of life table between the male and the female. Let's say if you just look at one of them. Let's say if we look at okay. Let's say we look at just look at since over here is highlighted, right? Just look at this row. Okay, what do you see here? You see at the age of 20, for both male and female, all right, you see that the number surviving for male is only, I would say, is a 98%, 98.52% surviving rate for male. While you can see that the female survival rate is higher, which is 98.758%. Okay? Which is higher. Okay? Okay? And the expected remaining life over here is 54.35. And over here for female is 60.4. So which means for females at the age of 20, the surviving rate is actually higher than male.
Right.
That's one conclusion. And the second conclusion is the expected remaining life for female is actually longer also.
Okay.
For female. Okay. So this is the two conclusions we can get from this life table. And then you must be wondering, how do we get this table out? How do we get this table? Okay. It's by census or surveys done by the government. So they just go out, survey a sample of people, and then they can get this live table with all this data. All right. So these are the two conclusions you can get from this live table. All right. So the reason we want to learn about the concept of probability is with this live table as an insurance company, right? Then you can make better decisions when issuing insurance or selling insurance. Am I right?
Yeah.
So when you sell insurance, right? Can I ask you a question? Let's say for the age of 20, do you want to charge more premium for male or female? Do you think the male insurance buyer have to pay more, or the female insurance buyer will have to pay more for the same coverage of insurance?
Male.
The male will have to pay more, right? The reason is
They live less.
yeah, their surviving rate is less, plus their expected remaining life is also less. So that's why
Yeah.
they have to pay more. So-called the male insurance buyer is actually more risky, right?
Yeah.
It's more risky than the female. I mean, of the same age. So that's why they have to pay more for higher risk, right? Okay.
Yeah.
So it makes sense so far. Good. So let's move on. So the things to think about is, can you use the life table to estimate how many years you can expect to live? So what about yourself? Which age band you should be looking at? You should be looking at like what? 2020, right?
Yeah. Yeah.
So for you, your expected remaining life is about 54. So that means from this life table, you are expected to live up to 74.35 years old, right?
Yeah.
Okay. Then for me, I should be looking at the 35 already. Okay. So I have about 40 years left. Okay.
Yeah.
Good. So that's the first question we can answer. Can you estimate the probability of a newborn boy or girl reaching the age of 15? So which is this? So we should be looking at this. All right. Okay. The probability of surviving for a male is 98.5%. For the female is 98.9. And I really don't know why female have a higher surviving rate and they have a higher expected life span. Do you have any idea?
No.
I also have no idea. I don't know why female have a higher expected lifespan than male generally. All right. Next, can the table be used to estimate the probability that a boy will reach age 75? Yes, right? So you just look at this. So a 15-year-old boy will reach age 75. So 15 is here, right?
Yeah.
So to reach 75, yep. So number of surviving is this. Okay, you just read this. Okay. What about a certain girl will not reach age 75? Just minus that. All right. Okay. So yeah. So over here they talk about insurance company. Yep. Self policy. So you have answered that question already. Okay. So over here, yep, we just had a first taste of using the concept of probability and to answer some real life questions, giving this life table, right? Now, experimental probability. All right. So over here is a theoretical probability table. But what about experimental probability? So it means one is theoretical, one is experimental. Meaning you have to do experiment, right?
Right.
So experiment like what? Experiment like you throw a coin to see the chances of getting a head and the chances of getting a tail, right?
Yeah.
So let's talk about. So I have a coin with me right now. Do you have a coin with you?
No, I just spent all mine.
Okay, it's okay. I have a coin with me. I have a $1 coin with me. Okay. I have a $1 coin with me right now. Okay. So you should expect the chance of getting a head and a tail to be what? 50%, right?
Yeah.
Okay. Okay. Okay, I think we need to make some assumption here. Okay. When we make such a conclusion, the assumption here is the trials must be large enough. Do you know what I mean by that? Large enough? Meaning that if we do enough trials, then only we will achieve this probability, right? So let me do just a very small trial, okay? A small trial, probably like 10 times. Okay?
Yeah.
Let me just do it 10 times. So I'm going to do it 10 times now on the spot. Let's see if we can get, let's see what is the probability to get a head and a tail from these 10 trials. All right, so I'm going to just toss a coin now. Okay, the first time round I get a head. So I'm going to toss the second time. Okay, I get a tail. I get a head. I get a tail. Okay, I get a tail. Okay, I get a head. Okay, I get a head. I get a head. Okay, I get a tail. Okay, last one. Okay, I get a tail. All right, so let's tabulate this result. Okay, so out of 10 times, I get 1, 2, 3, 4, 5. 5 hits, and I get 5 tails. So what it says from this experiment is, so the chance of getting a hit is 50%, and the chance of getting a tail is also 50%. All right. So even with a small trial like this, okay, I can get my experimental probability, okay, to be exactly like the theoretical probability. So this probability is called a theoretical probability. Okay, while this one is experimental. All right. Okay. So far so good.
Yeah.
And I will say my experimental probability converge with the theoretical probability in this case. All right. But throughout these 10 talks, all right, I hope you realize one thing. Okay, from here to here, okay, the 6th, 7th, and 8th talks, do you see what you see? Head in consecutive, right? Okay, so with this, let's say this, the 9th and the 10th is not known. All right, let's say we stop this experiment at 8, right? And then just because that you see that, oh, I have H in a row, so you tend to think that what? You tend to think that, oh, the chance of getting a hit in my 9th toss is actually higher. All right, you might have this so-called illusion. Okay, the chance of getting a hit for the 9th toss is higher. Why? Because over here, the 6th, 7th, and 8th toss, it gives you an illusion. All right, you have a H in a row. Okay, and then that's why it gives you an illusion that you might get a H in your 9th toss. Okay, you have a higher chance of getting that. But actually, in fact, what? In fact, the probability of getting a H in the tail for the 9th toss is actually 50%. And the illusion of having a H for the 9th toss, right, is actually quite a very common phenomenon. All right. All right.
Mm-hmm.
Do you realize that the the phenomenon of estimating or the phenomenon of guessing what is the result of the knife toss, I think most of the people will say the chance of getting a H is higher, right? I think that is a common phenomenon, right? The chance of getting H for the knife toss is actually higher. But in fact, it's not higher, okay? The fact is, okay, regardless what happened in the past, okay, the chance of getting a H and a T is both 50%. Okay, do you get that? Do you get it?
Yeah.
Okay, so I'm talking about our experiment just now. The 6th, 7th, and 8th toss, they are both hit. So you might be thinking that, oh, for the knife toss, the chance of getting a H is higher.
Oh. Yeah.
In fact, it's not true. It's not true. Okay, so don't get yourself into this illusion. Okay, it's an illusion. Okay, in fact, the knife toss, the chance of getting a H or a tail, they are both 50%. Okay, they are
Yeah.
both 50%. Okay, so that's the reason why. If you look at the question I asked you just now about the Chinese stock market tomorrow, what will be the result, or what will happen tomorrow for the Chinese stock market, right? In fact, the chances of up, flat, and down remain the same. All right, remain the same. It's 1/3 for up, 1/3 for flat, and 1/3 for down. All right, so don't fall into this common illusion. All right, all right. So that's something we need to guide ourselves against this illusion. All right. Next, over here they have a different experiment of tossing a drawing pin here. Okay, we toss a coin just now. Okay, so let's look at one of the questions. All right, so let's look at question 3 here. Okay, so what it says is this guy records the number of phone calls she received over a period of consecutive days, right? So for how many days did the survey last? So number of calls per day, okay? This is number of days. So for how many days did the survey last? So it lasts 10 days, right?
8 days.
Pardon?
10 days. No,
Yeah.
8 days, yeah.
Okay, so what here says is, okay, number of calls per day. So 2 days, you have 0 calls per day. For here, you have 7 days of 1 call per day. All right, and then you have what? You have 11 days of 2 calls per day. Okay, and then you have what? How many days? You have 8 days of 3 calls. So this is 2, this is 7, this is 11, this is 8. So you have like 7 days of 4 calls, and then you have 4 days of 5 calls, 3 days of 6 calls, 0 days of 7 calls, and then 1 days of 8 calls. So how do you get the how many days did the survey last? You have to add up, right?
Yeah.
You add up all this. That will give you the number of days this survey lasts. All right. So now, estimate Batu's chance of receiving no phone calls on 1 day. So no phone calls on 1 day. So how do you get the probability? No phone call.
1 of 8.
2 of them, right?
No, 1 of 9. Well,
Oh,
2. 2 of what? 2 of
the total, right? Which is we
Yeah.
need to find from here, right? Okay. So let's find it out. This is 9. 11 is 20. 20 plus 15, 35. 35 plus 8. 35 plus 8 is 43. Right? So 2 out of 43. So the chance of receiving no phone calls on one day is 2 out of 43.
Right.
5 or more. So you look at here, which is 8, right? 8 over 43. Less than 3. So look at this. So 3 is not included. Less than 3, so it's just here, which is 20. So it's 20 over 43. Okay. Simple?
Yep.
Yep. Pretty simple. Okay. Next. Okay, over here they have a coin tossing experiment. I just did that, right? I just did that, right? Okay.
Yeah.
What I did just now is this. What I did just now is, if I were to just get this out, right? So the tally is what? The tally is 5 for head, and then 5 for tail, which is head. Okay, so this is actually tail, right? So the frequency is what? The frequency is 5 out of 10, right? This is also 5 out of 10. Hold on. I think the frequency is 5 times. This is also 5 times. Then the relative frequency is 5 over 10. This is also 5 over 10, which is half. If I were to fill up this table, that's the way I will fill up this table. Yeah.
Okay.
All right. So next. Okay, over here they ask you to do more times, toss 2 coins 60 times. Okay, so over here, what they want you to see is like, they want to see whether this experimental probability actually converge with the theoretical probability or not. All right, so we did the experiment just now. Okay, surprisingly, my experimental probability converge with the theoretical probability. Okay, which I don't expect it to be. Why? Because I think my trial here is too small. Okay, I only did it 10 times. Okay. Right? Well, in order for the experimental and theoretical probability to converge, a bigger trial is needed. Probably like 100 times. Yeah, is needed to have a good enough number. Okay.
Okay.
All right. Okay, over here, sample space. All right. So a sample space is the set of all possible outcome, so which is referred to as the universal set U. So over here we will touch the concept of set. Okay, the idea of set. Okay, so you have a Venn diagram as well. So that like it says, there are a variety of ways of representing sample spaces. The tree diagram, the Venn diagram, the table outcome, list, and 2-dimensional widths. Okay, so these are a variety of ways to represent your sample space. Okay, we will touch upon all this later on. So list the sample space for possible outcome for tossing a coin. So by the way, our example here, we are using what? Listing. Okay, the first one, listing. I listed down all the possible outcomes, which is over here. Okay, so I just did this listing. Okay, I just did the listing just now for my tossing of a coin, right? Over here, I don't have a dice. I mean, yeah, I don't have a dice. Okay, so I can't roll a die for you, right? But this is listing. This is also listing. Okay. Now let's look at the second way of representing the sample space. It's called a 2-dimensional grid. Okay. So the 2-dimensional grid is here. Okay. So you have coin 1. The possible outcome is H and T. And for your coin 2, the possible outcome is also H and T. So what do we have here is, you have a coin 2 and coin 1. The possible outcome for coin 1 is H and T. And the possible outcome for coin 2 is also H and T. And with this, you get a 2 by 2. I can call it a matrix. Okay. And then with this, you have 4 possible outcome, right?
Yeah.
Yeah. So this is called a 2-dimensional grids. You call it a two-dimensional grids. All right. So what if the question is slightly changed to this? So let's say for this is a coin. So the number of outcomes is either H or T. And then for this is a die. So you have 1, 2, 3, 4, 5, and 6. You have 6 possible outcomes for a die, right? So your sample space is given by this 2-dimensional grid. Okay? So the total number of outcomes will be given by this sample space, which is represented by 2D, they call it what? Grid. So over here, a die and a coin, you have 12 possible outcomes. And these 12 possible outcomes is the sample space. So 2, 3, 4, 5, 6, yeah, 12. Okay? All right. So
Yeah.
I think a 2D grid, right? A 2D grid is actually a very simple way to represent your sample space. Okay? If you have 2 events, all right? Okay? Over here, you have a die and a coin, all right? Now, let's look at another way of representing your sample space. Over here is a tree diagram, all right? A tree diagram, okay? Oh, all right. So far we have what? We have introduced the list and the 2D grid and the tree diagram. Okay, so let's look at the first question. The question says list the sample space for the following twirling a square spinner labeled ABC. So the sample space is either A, B, C, or D, right? Right?
Yeah.
Then what about the sexes of a 2-child family? So you have a mom, you have a dad, and then you have the first child 1, and then you have the child 2, right? So for the mom it can be. So for mom is what? Definitely female, right? For dad is definitely male, right?
Yeah.
And then for the child it can be male or female. So for this child it can also be male or female. All right. So your this sample space is a female mom, and then a male dad, and then you can have a male child, and then you can also have a female child. And then you also have a male child for the child 2, and then you have a female child 2 as well. So these are your sample space. 1, 2, 3, 4, 5, 6. 6 of them for this. All right.
Yeah.
Yep. So that's how you list them down to represent the sample space. All right. So now let's look at this question 2. So I will pass question 2 to you. Over here, you are asked to use a 2-dimensional grid. Okay. What about this? Can you get this? Can you try 2B to draw the sample space? can you do a screenshot of this and yeah, show your desktop? How do you get this? You can do it in Excel as well. Are you sharing your screen?
Yeah.
All right, let me stop share first. So yeah, share your screen.
Yeah.
All right, yeah.
2 days.
So yeah, this is the 2D grid, right? So how many? So can you tell me how many possible outcomes you can get? Hello.
Hello.
Yeah. How many possible outcomes?
36.
Yeah, is 6 times 6, right?
Yeah.
Yeah, good. So what is the next question?
I don't know what's the next question.
Okay, all right. Let me just take a look at what's the next question. Okay, the next question is rolling a die and tossing a coin. Oh, I just did that. Okay, I just did that. And yeah, that's it. That's it for for question 2.
I'll stop sharing.
Yeah, please. Thanks. Okay, shall we take a break before we move on? Yeah.
Yeah.
Okay, see you in a while.